Hey guys, welcome back to what is probably going to be another long video. Today's topics are going to be functional groups. Um, now, in the last video, we discussed the most basic type of organic molecule, which is the hydrocarbon. Now, these are actually pretty boring, and the way we can spice things up is by adding functional groups, which are structural units consisting of a group of atoms or potentially one atom that serve as a site of chemical reactivity in an organic molecule. And in the next video, we're going to see all the different types of reactions um, these functional groups can do, and then we call a group of organic molecules that contain the same functional group a class of organic molecules. So this is a function. This is an example of a functional group. This OH group, which is given the name hydroxyl, and we generally call these we generally call all organic molecules that have this OH functional group um, an alcohol. So the alcohol is the class. So an alcohol is a class of compounds which all contain hydroxyl functional groups. These things here. Um, so here's sort of a little summary chart of all the functional groups you're expected to memorize. Um, this big table here that you're expected to pretty much memorize. Um, you're not expected to memorize the whole thing. What you're expected to memorize are you're expected to memorize class name, functional group name, uh, either one. You're expected to memorize class name, functional group name, either the full structural formula or the condensed one, and their ending of the IUPAC name. So while it's still certainly a lot, uh, the best way I can the best way I can help you here is flashcards are really your friend here. Uh, there's some on Quizlet that I know of. I might link to one in this video's description if I can find the effort to do so. But yeah, you're just gonna have to memorize it and suck it up. Um, so so here's some nomenclature that you're expected to know with certain functional groups. So double bonds and triple bonds technically count as a functional group, and they do actually have some important reactive properties that we will get into in the next video, and the higher levels will discuss quite a bit in detail. So these are the alkynes, which basically they apply the same naming rules apply for alkenes and alkanes, except their ending is "-ine", Y-N-E. You're and you're expected to know how to name them as well, name compounds with them. So with these functional groups, the next main the next we're more or less going in order of simplest to hardest functional groups to understand. The next one is the halogene alkane, which halogens are treated like branches when naming an alkane. Um, and for reference, and they basically are treated like hydrogen atoms because in many ways they do have some reactivity associated with them, which we'll get into later. But for when you name them, you use chloro for chlorine, bromo for bromine, so on and so forth. So this is fluoromethane. This is 1,1-dibromoethane. Again, since bromine is the highest order functional group here, you name it from the side. You start your numbering based off whatever gives this the lowest numbers. So if you name from this side, it's 1 1. 1 is lower than 2. So yeah, here's 1-chloro-3-methylbutane. Since chlorine is the highest order functional group, highest or priority functional group here, that's sort of you name it from this side 1 2 3 4. You name it from one here. Also, too, this list generally tends to go in terms of order of functional group. With like this list that I'm listing everything here in terms of lowest to highest order. Um, in terms of lowest to highest order that you'll see in IB. In university, there's a formalism associated with this idea of um, highest priority functional group. But for now, I'm just going in what you'll essentially consider the lowest to the highest priority. The the one that's higher up on the list that comes after bromine is alcohols, which have the ending -enol. So carbon number 1 is the end closest to the hydroxyl group, and indicate the carbon number 1 is the end that's closest to the hydroxyl group or the highest priority functional group, as I've stated many times before. So this is methanol, this is propan 1-ol. Note here you put the number where the highest order functional group is, like right in between. You split the ending, you split the name up, and number where the highest order functional group is, and then the ending of the name. You sort of split the name up, and then 6-methyl-heptan-2-ol. Again, you notice how you split the name up. For the next, the one that's higher up is the ether, which and ether consists of ether, whatever. It consists of 2 carbon chains connected via an oxygen atom. There are two ways the IB will accept you naming them. The common method, which is known as alkyl-alkyl ether, which basically you name it alkyl group 1, alkyl group 2, and then ether. And then the officially sanctioned IUPAC method is alk-oxyalkane, where the alk-oxy branch is the shorter branch. So this would be considered an alk-oxy branch, and this is the main branch. This is the main. This is the main sort of branch, and then these are side branches. So you could either call this ethyl propyl ether. Here's where the ethyl comes from. Here's where the propyl comes from. You could also call it propyl ethyl ether. It's the same thing. It doesn't matter what, but generally you typically, again, you alphabetize them in the name. Yeah, you alphabetize them. If you do it this way, E comes before P in the alphabet, so you name it ethyl propyl ether. So this is an ethyl branch. This is a propyl branch. Ethyl 1, 2, propyl 1, 2, 3, and then ether indicates that this oxygen is connecting the 2 branches together. Whereas if we go via the new naming, the officially sanctioned IUPAC method, this is a propane 1, 2, 3, and then this is the alk-oxy branch. So eth-oxy-propane, eth meaning two carbon atoms, oxy meaning an oxygen atom at the end of them, and then propane indicating the longest continuous chain. So here's some more examples. So methyl ether, dimethyl ether, whereas this is methoxymethane, ethyl propyl ether, ethoxypropane, and then ethyl 2-propyl ether. So remember, the reason for this 2 here is because it's the oxygen is attached to the second carbon of this propyl group, and then if we were to use the alkoxy method, this would be 2-ethoxypropane, since the ethoxy branch is on the second carbon of the propane molecule. So I prefer this new method. You can use the old method. Either one is acceptable for answers. The functional group that is higher in order is the aldehyde, which gives the ending an al, and you don't need a number to indicate where it is, since it's always going to be on carbon number 1, because it's when we go into studying ketones, that actually does need a number, whereas for aldehydes you don't typically need the number since they're attached to an end. Since the ending they're attached to is always number 1, so this is pentanal, this is methanal, this is bromobutanal, 3-bromobutanal. Thank you, Windows, I don't care. But in an aldehyde, the aldehyde functional group must be located on the end of the carbon chain, and that is always designated as 1. Since this is always the case, you don't need a number to denote its location, and it's this double bonded O that is considered to be an aldehyde functional group. The next highest priority functional group is the ketone. It's similar to the aldehyde, except it can be anywhere in the middle of the molecule that is not the ends of it. So you do need a number to denote its location. So this would be propan-2-one. You're given the ending -one, and you split. I think it's the vowel sound. I don't know. You put the number in between the vowel sounds if there's 2 vowel sounds there. You do the first vowel sound, the number, and then this last vowel sound. I think that's how you split it, but I'm not a linguist. Ask someone else about that. But this would be propan-2-one, this would be pentan-2-one, propan-2-one, 1, 2, 3, The ketone is on carbon number 2, pentanone 1, 2, 3, 4, 5, and then the double bonded oxygen is on the second carbon here. Lastly, the two highest order, the second highest priority group is carboxylic acids, which give the ending anoic acid. Um, and in a carboxylic acid, the carbon functional group must be located on the end of the carbon chain. So you denote that carbon number 1. So therefore, you don't need the number to designate. You don't need the number, more or less. You can just say, so this would be methanoic acid. This would be propanoic acid, because this COOH group must always be on the end of the molecule. So this would be 4-fluoro-3-methyl-butanoic acid. This would be propanoic acid. And then lastly, we have the ester, which ester naming is a bit weird. When we go into discussing how they're actually made, it does make quite a bit of sense, but the way you name esters is the carbon that is attached to both oxygen atoms is given the basically it's the main branch. It's considered the main branch, whereas this side branch here would be given the this would be described as a side branch. So this would be methyl methanoate. This would be 1-propyl ethanoate, since the oxygen attaches to carbon number 1 here, and this would be 2-propyl ethanoate. Note here that how, even though this is technically a shorter hydrocarbon chain, since it has the highest order functional group, that since it has the highest priority functional group, those two oxygens there, it's denoted with that. It's given the special recognition it deserves by being considered the main chain, and then the 2 comes from the fact that this propyl here is attached at carbon number 2, and then propyl describes the length of this carbon chain, 3, the length of that branch, 3 carbons. Different structural isomers can have different functional groups, kind of a given. So here's an example of that: propanoic acid and then methyl ethanoate. That would be 2 suitable isomers for this molecular formula here. I think that's there are these sample questions here. However, I think I'll do a separate video with worked examples, because this video is, and some of these videos were already getting quite long as is. So hopefully you enjoyed the video. Don't forget to like and subscribe, all that stupid shit. See you later.